Let n be a positive integer. The coefficient of x to the 3, y to the 5 in the expansion of 1 plus xy plus y squared to the n equals n, 2 to the n, well, a bunch of these options. Okay. Interesting. So I mean, if this were specifically about the binomial theorems, I'm sure this would be a lot more straightforward. There's probably some kind of general expression for the coefficients of a trinomial expansion like this. I mean, one of the keys to recognize here is that, in order to construct a term of the form x cubed y5, we need the middle term in this trinomial to be multiplied by itself 3 times. And then that has to be multiplied by the last term once. And so, yeah, I think this is going to end up being, this might be like, end up being a bit of a combinatorial problem, because if I have multiple copies of this thing, so in total there are n copies here, I'm worried about the result of the coefficient x cubed y to the 5. So that means this thing has to get multiplied by itself 3 times, and then this thing has to be picked up once. But it does, I could take that one and that one and that one, and then also that, or I could take that one and that one and that one, and take the y squared from there. So of n buckets, we need to choose that out of 3 of them and that out of 1, and we want to count up how many different ways we can do that. So because we're only looking for one of these, let's take one factor and set it aside and say that that's the one corresponding to y squared. There are n ways of doing that. And then we're left with n minus 1 buckets, and we need to choose 3 of them. So does this simplify into something? It's not written in the question. It just says that n is a positive integer. We have to assume that n is greater than or equal to 3. In fact, it has to be greater than or equal to 4, doesn't it? And I think this does correspond to one of the options, because this is the same as n factorial over n minus 4 factorial times 4 factorial, but then we multiply by a 4 up here. And this is 4, n choose 4, which is option D. Yeah, I mean, I'm pretty confident in this. My combinatorial skills are not very good, but it seems to make sense because we know we only want one of these to appear. Let's just arbitrarily choose one of the buckets is corresponding to that term being chosen, the y squared, and we'll remove that bucket. From the remaining n minus 1, we have to choose 3 of them that contribute an x times y. So that happens this many times. But the original choice of the term that gives us the y squared, there's n different ways of doing that. So multiplying these together gives us 4 times n choose 4. I'm pretty confident in this, but I'm going to check the answer to make sure that I've gotten it right, and I'll put it down in the description in case it's not. Thanks for watching.